Hey everyone, this video is going to be talking about Chapter 3, Section 2, Solving Systems of Linear Equations. In the last unit we talked about graphing as a method to solve the systems. Today we're going to be talking about substitution and elimination. So we're going to review the technique of substitution. So the first idea here, and the way that we're going to solve this, is starting by isolating one variable in one equation or the other. It doesn't matter which one. Let's make this a little bit smaller. So I'm going to do the second equation just because it's nicer to isolate, because the y is already by itself. So when I isolate this, I get a new equation that is y equals negative 3x minus 9. Once I have isolated one variable, I'm going to take all of what I've just isolated and I'm going to plug it into my other equation. So I'm going to do that down here. I know 4x minus 5. If this is equal to y, I should be able to plug in everything that y is equal to in for y. Finished up. Once we get here, we should be able to solve this. So we're going to solve this by just simplifying. I'm going to write 4. I really like that over here, possibly. So I'm going to do 4x, and then I'm going to distribute. So it's going to be plus 15x. Negative 5 times negative 9 is positive 45, and it equals 7. Combine your like terms, move everything to one side, and you end up getting 19x equals negative 38. When we simplify, we get x equals negative 2. So after we've isolated that variable, I'll put my second note here, we plug in these, what y is equal to into y in our other equation. Hopefully that makes sense. That's where I took this and I plugged it in up here. After I've done that, I solve for the variable. Now we're on step 4. Now we are taking the variable we solved for, take variable, and plug it into either equation in order to get second variable. So for this, I'm going to take all of this, move it over. Nope, I'm not, I guess. I'm going to take this and move it so it's out of the way here. What I'm going to do is I'm going to take this and plug it into one of these. I like this one because there's no coefficient in front of y, but you could plug it into the other one and it works just as well. So if I go up here, I'm going to say 3, negative 2, because I'm plugging my negative 2 in for my x, plus y equals negative 9. From here, I just solve, and I get y equals, well, negative 6, add that over, it's going to be negative 3. Again, I'm not quite finished. Even though I have an x and a y, I still have to put it in coordinate form. Negative 2, 3 is my final answer. So that would be step 5, write coordinate pair. So that's your final answer. And because you want to make your teacher's life easy, please circle it so I can find it easier. Excuse me. All right. Pause this video, go back, rewatch if you need to. Otherwise, I'm going to move on. The toughest type of elimination problem you'll encounter. The trick with elimination is get all terms lined up. So this first one's really easy because all the x's are on one side and all the y's are on one side and all of the non-variable terms, so your negative 2 and your 39, are on the right side. If they're not set up like that, it's really challenging to do this kind of problem. So I always just like to set it up like this. Once we've got it set up this way, I need something to cancel out. I need a variable to eliminate. But I don't see anything that would eliminate right now. However, I do notice that there's a positive 3y, and I've already got a negative going on here. So if I could just make this a negative 3, well then I would be able to cancel and eliminate my y's. But I can't do that. Well, I can if I plug in, or if I multiply this entire second equation by 3. I'm going to take this and I'm going to move this up and move this one down. If I do that, I get 21x minus 3y equals 3 times 39, which is 117. Notice everything is still lined up. We're still good to go there. Except now, things do eliminate. So now if I add these down, I notice that my negative 3y and my positive 3y cancel out, and I can just add everything else. So I get 23x on my left side, and on my right side, I get 117 minus 2, I get 115. Simplify one step further here, and I get 115 divided by 23. I get 5. X equals 5. From here, I guess I'll put my next step in. This would be multiply one or both equations such that one variable has a positive and a negative version. Once one has a positive version and one has a negative version, that's where the elimination comes in, which is what you see here. So from there, we add down on remaining like terms and simplify, which is just this final step here. From there, it's the exact same steps as the last problem we did with 4 and 5, where we take the variable, plug it into either equation, and then write it as a coordinate pair. So if I plug 5 back into either of my original equations, up here I'm going to get 35 minus y equals 39. If I solve that real quick, I can tell you that it's going to be negative 4. So my final coordinate pair is going to be 5, negative 4. We know that works because if we plug those back in, it will work for both equations. So the three methods that we have talked about are methods involving graphing, substitution, and elimination. Hopefully this video has been helpful. Please come and chat with me if you have any other questions.